So this guy here has to be 40 volts. And this guy here has to be 40 volts. That's V1 and V2. Then we know this is 40 volts. We know the current through 2 is 3.3 amps. We can use that to find resistance. V equals R, so R equals V over I, so that's going to be 40 over 3.3.
But if you were to find the current using the first resistance, so V1, R1,
Yeah.
how is that?
That would give you the current just through this branch. So if you wanted to do it that way, you would use, so I would be equal to V over R. So this would be 40 over 6, which would be 6 and a bit.
Yeah.
6 and...
Then it would be 6.66.
Yeah, it would be 6.6 repeating. Yeah.
But then, how does that relate to what the current actually is?
So the current through 1 would be 6.6 repeating. That's just for this chunk here. This chunk here is 3.3, which tells us that this chunk here is going to be almost effectively 10 amps coming out of the source, because it splits here. 6.6 goes this way, 3.3 goes this way. Does that help at all?
Why would there be 10 amps at the top?
Because we just found this branch to be 6.6,
Yeah.
and we're told this branch down here is 3.3. So then going into this junction has to be the sum of these two.
Oh, okay.
6.6 repeating plus 3.3 is 10.
Okay.
So we could do it that way. We could find the resistance down here through that method. Now that we know total current, we need to find total resistance. We could do it that way too. Total R total is going to equal V total over I total. V total is 40, I total is 10, so total resistance has to be 4 ohms. And then we could use that, because these two are in parallel, 1 over RT equals 1 over R1 plus 1 over R2. So we know that 1 over 4 minus 1 over 6 equals 1 over R2. And we could go through it. We could find resistance that way too. Does that help, Nia?
Yeah.
Okay. You wanted 3? Okay. What is the potential difference supplied by the voltage source? We know. Okay. So we know current going through this portion of the circuit is 8 amps, and that resistor is 3 ohms. And we know these two resistors are the same. Okay, so there's some reasoning we can do here. What can we find based on what we're given? I am. Yes, Luis, I am. Thank you.
Well, I figured that we could do voltage equals I times R.
Okay, for this piece right here? Or for what piece?
No, I did it overall, like for the whole thing.
Oh, yeah, okay.
So I did V equals 8, which might have been my mistake because I kind of assumed that the voltage, or not the voltage, but the current was, because it was 8 after that resistor.
Yep.
For I1 and I2 after the resistors, so I think I know it.
But because no, this current is the main branch. So this current is equal to the total current.
Right.
You can use 8 here.
So,
But how did you come up with the total resistance?
okay, so I did 8 times 1 over 3 plus 3 plus 3.
That's going to be your
Mistake.
Because if you want total resistance, the resistance for the parallel portion, 1 over R parallel is going to equal 1/3 plus 1/3, which gives us 1 over R parallel is going to be 2 over 3. So RP is 3 over 2. That's just for these two. That make sense? So then if I were to draw the equivalent circuit for what I've just found, it would look something like this, where we know this guy here is 3, and I can replace these two in parallel with one here of 1.5, which tells us that and because these two are in series, that tells us that the total resistance of this whole circuit is what? What do we do when the resistors are in series?
I think, when the resistors are in series, they're added to make the total.
Yeah. So that's going to give us a 4.5 here. It's exactly going to be 36. That's one way you could do it. There are alternative ways to do the same question. Yes, Angelina?
I just did V equals I over R, and then I did.
V does not equal I over R.
I mean, sorry, V equals I times R.
Okay.
And then I did 8 times 3 times 8, but I don't really know why I did that. But I got 36.
I also don't know why you did that. Eight times 3 isn't 36, it's 72.
Yeah.
So, I mean, here's an alternative way to do the same question. If you do V equals I times R and you do 8 times 3, that just gives you the voltage taken up by this resistor here. 8 times 3 is 24 volts. And now we need to figure out what's left for these two pieces here. Now, we can reason our way through this. These two resistors are the same. So what can that tell us about the current traveling through these two branches? They're the same. And current splits. So I would have to split 8 amps equally to send some down here and some down here. So yeah, the current through 2 would have to be 4. And the current through 3 would have to be 4. Because these two resistors are equal. And so the current would split equally. So then you could use V equals I times R. To give you 12. Well, it's also going to be 12 down this branch. But in parallel, voltages don't add. The branches have to be the same. So you'll take the 12 volts eaten up by the parallel portion and the 24 volts eaten up by that resistor there. Add those together to get you the 36 total volts required. So that's an alternative way you could do the exact same question.
Instead of before we assign this number, the easiest way to solve the question was just answer like for everything and just figure out.
Often, yeah. But there's more than one way to skin a cat, as my uncle would say. Skinning a cat's very difficult to do. There's more than one way to do it, apparently. But often an easy way to find, and so the find everything method would be this method that I did here in pink. Just find all of the pieces. But these things are puzzles. You can do them all sorts of different ways. Questions about 1 or 2? Okay. Do you want me to do another one? Okay, flip the page. Let's take a look at another one. Where's a fun one? You know what? I will randomly generate a question between 5 and 18.
Which one are we doing?
I'll find out in a second. We're going to Google. The minimum number is 5. The maximum number is 18. I'm going to do question number 13. Flip ahead. Let's look at 13. Okay. So, question 13 says, what is the value of the total current in this circuit and the power dissipated by R1? So now we're going to start bringing power into these things. So we've got two sets of equations that you're working with. V equals I times R and all of those derivations. So V equals I times R, I equals V over R, and R equals V over I. Those three. And then you've got all the power equations, which came from this section way back at the beginning. These here. P equals I squared R, P equals V squared over R, and P equals I times V. So those are the equations that we're dealing with here. So I'm going to write them down. We got P equals IV, and we're using V equals IR, and those two will give us everything that we need. So we're told that 15 volts is supplied by this source. We've got 6 ohms, a 6 ohm resistor here and a 3 ohm resistor here. These two are connected how? In parallel. And we're asked to find two things. One, the current on the main branch, and we're asked to find the power dissipated by R1. So does anyone see a place we could start? There's a few things we could, there are basically two first steps. Either one, choose your own adventure. One will take you down one path, one will take you down the other. Connor, what do you see we could do first?
Well, we have a total voltage in the battery, so we could do the total voltage equals IR because we have both resistors as well.
It's true. So you want to go that route. VT equals IT times RT. What is, we have to find RT then. So what's RT?
Well, in parallel, I believe the resistances are 1 over R1 plus R2 plus R3.
Okay, so 1 over the total resistance, because these two are in parallel, and those are the only two that are there. We can do 1 over RT is equal to 1 over 6 plus 1 over 3, which is going to be 1 over RT 1/6 plus 2/6 is going to be 1 over RT is going to equal 3 over 6, which is 1 over 2, which means RT equals 2. We cool with what I did there? Okay. So then total voltage is the 15 volts. The total current is what we're looking for here. The total resistance is from those two combined is 2 ohms. So my total current is 7.5 volts. Amps. 7.5 amps. Okay, so what now? So I can add that to my diagram. I right there is 7.5 amps. Now I want to find the power being dissipated by resistor 1. How could I go about doing that? V is equal in these two branches because they're in parallel. And there's nothing else eating up voltage. So yeah, this is going to be V1 is going to be 15 volts and V2 is going to be 15 volts. And then we can just do the math. Power dissipated is equal to, there is a relationship that involves V and R. It is it V squared over R? I think it's V squared over R. Go back. Yep, P equals V squared over R. So then the power dissipated by that resistor is going to be 15 squared divided by 6. 15 squared is 225 divided by 6 is not something I can do in my head. What is the power dissipated by that resistor?
37.5.
Watts. There we go. Done. Questions? Okay. That's all it is. It's playing with these facts that we've looked at before and the equations that we've got that relate these concepts together. But you've got you've got to be willing to play with these things. That's where it's going to get difficult, is because you're often not going to be able to see immediately how to get to where you want to go. You just have to start taking steps. There's a profound quote somewhere in The Lord of the Rings or The Hobbit about doing that. Just go. So I'm going to leave you the rest of the class to work on the rest of this. We'll see how you guys do. I'm happy to offer whatever assistance is necessary, but again, the only way you're going to get good at this stuff is to, and comfortable with it, is to play with it. So we will, after you've had a chance to play with this stuff, we will do another GeoGuessr, yes.
Fair enough.